Okay, here's a test review for tomorrow's test. First part of this, we're going to solve these equations algebraically. We can use a calculator to check the correct answer. I'm probably not going to do that, but we will have to check our answers to make sure that they work. And I guess maybe I'll show the calculator too. Alright, first one. We need to get, our first thing to do is get the radical by itself. To get the radical by itself, we have to clear everything else out from around it. First thing we're going to do is add 3 to both sides. Once we add 3 to both sides, we get square root of 3t minus 5 is equal to 7. My radical is by itself, so what I'm going to do next is square both sides. Square that side, square that side. I get 3t minus 5 is equal to 49. I've gotten rid of my radicals successfully. What I'm going to do next is solve for t. I'm going to add 5, so I get 3t is equal to 54. And the last thing I'm going to do is divide by 3. If I want to use the calculator, you can always use it for little pieces. 54 divided by 3 is 9. Wait, no. 54 divided by 3 is 18. So I have t is equal to 18. I don't know if that's a solution yet, because before I know that's a solution, I have to test it into the top. To test it, I'm just going to plug it back in that t. So in the calculator, so I don't have to do a bunch of work by hand. If on the test, you'll have to do this by hand and show it what you did. So square root 3 times t, which is 18. And notice how the radical keeps going on top of my numbers. Minus 5. And look, I have to press the right arrow, and now I press the right arrow, so now I'm out of the radical, and I do minus 3. If this is right, if this is a good solution, I should get 4. There it is, 4. So this equals 4. 4 equals 4. That's a true statement. This is my solution. Let's look at another one. Let's look at number 5. Let's go with number 5 here. On number 5, I'm going to do the same thing. I have to make my radical by itself. To get my radical by itself, I have to get rid of this 4. To get rid of this 4, I need to divide the entire side by 4. When these divide, that disappears, and I'm left with the square root of x minus 3. 8 divided by 4 is 2. Now that I have my square root isolated, I'm going to go ahead and square both sides. Square, square. When I square this, I get x minus 3 is equal to 2. After I square both sides, I can go ahead and solve for x. This one's nice and simple. One step. X is equal to... Oh, I'm sorry. The squared is 4, which means that 4 plus 3 is 7. Sorry about that. So that is 7. Let's test it. Again, to do that by hand, to test this by hand, you need to go for the square root of x, but instead of x we put 7 minus 3, and that should equal 8. I am not going to do that by hand. I'm going to test that in a calculator to make sure that works. So I have 4, the square root of 7 minus 3, and I Oh, that's all I need. 8. 8 equals 8. We're good. This is a solution. That is a solution. Let's look at number 9. Let's look at number 9. Number 9, I need to get my radical by itself. I need to get my radical by itself. This 2 over here is stopping that from happening. Oh, we have an x over here too. So let's go ahead and let's subtract that x over here, the 2 over here, subtract that 2 over there. I now have the square root of x minus 2 equal to x minus 2. Here's where this can get a little complicated. I have to square both sides. When I say square both sides, I really mean you need to square both sides, the entire side. So I square that side, and that's going to get me x minus 2. We're good at that part. It's this part over here. I need to do the entire side, which means I need parentheses over here. X minus 2 squared is x minus 2, and we have to use the box x minus 2 like that. That's how we have to do x minus 2 squared. X times x is x squared. X times negative 2 is negative 2x. Negative 2x down here as well. And then for the last box, negative 2 times negative 2. Negative times negative is a positive. That's a positive 4. And remember, there is a peanut value here. So my equal sign here should be x squared. Negative 2x plus negative 2x is negative 4x. And then I have my plus 4. So what's happened is, once I've squared both sides, because I have this extra x in here, I get a quadratic. When I get a quadratic and I have to solve for my solution, I need to move everything to the side with the x squared. So I'm going to subtract x and add 2. Subtract x, add 2. I get 0 is equal to x squared minus 5x plus 6. You can do the box method, expand it out, and get the factors. Or I can plug this in the calculator. I'm going to go ahead and clear this off real quick. And I'm going to plug that in. X squared minus 5x plus 6. Once I have it in here, I'm going to go to the table. And I want my zeros. I want to know where it's equal to 0. So I have zeros. Actually, they're right close to each other. I have zeros at 2 and 3. I have zeros at 2 and 3. That's where I get y1 equal to 0. So I need 2 and 3. So I have x is equal to 2 and x is equal to 3. But I have to test both of those. So in my calculator, I'm going to quit, and I'm going to plug those into this equation up here. So I do 2 plus the square root of x, and x I'm going to put 2 in parentheses, minus 2. That's the first one. I test that one. 2 is equal 2. And on the other side I would have had 2. My x is 2, 2 will equal 2, we're good on that one. So that's the solution. Now let's test the 3. So I'm going to go back up here, where that 2 is. Now this one should equal 3, because I'm plugging 3 in for x. And both of those work. Both of these are solutions. Let's see. Now let's do, oh, look at that. We got tic-tac-toe. I win. Alright, let's do 8 now. Actually, let's not do 8. Let me pause this. Alright, I'm going to go ahead and do number 7. Number 7 is a lot like number 9. It's probably... Alright, sorry about that. Back to 7. On 7, we're going to more than likely end up with another quadratic. On this one, when I start off, the left side is already isolated with the radical, so I can start by squaring both sides. Remember, we square both sides, we have to square the entire thing over here. This is going to be x plus 1 equals, square this, let me draw the box small over here, x minus 1, x minus 1, x squared minus x, and that's 1 in there. So this is going to be x squared minus 2x plus 1. I have this quadratic. There's a squared right there. If I have a quadratic, I have to move everything to the right side, or to the side where the x squared is. So minus x minus 1, minus x minus 1. I line everything up. I get 0 is equal to x squared minus 3x. And there's nothing here because 1 minus 1 is 0. So that's my quadratic there. Let me go ahead, even though it's probably not the simplest, there's another other way. I'm going to go ahead and just put that in the calculator. Go to y equals, and x squared minus 3x. And I look at my table. I try to find my zeros and want to know where it's equal to 0. I have a 0 at 0, and then I have another 0 at 3. So 0 and 3. So 0 and 3. X is equal to 0. X is equal to 3. Now we have to test those. Thing with this one is we have to test both sides, because we have to actually do some work on the other side. The right side is fairly easy though. So left side we have the square root of x, and my first x I'm going to test is 0, and I'm going to do plus 1. If I plug 0 in the right side, 0 minus 1 is negative 1, so hopefully this will get us negative 1. It does not get us negative 1. It does not get us negative 1. So this is called an extraneous solution. Let me show you that by hand. So you have to do this, you'll have to do this on a test. Square root of 0 plus 1 is equal to 0 minus 1. This is the square root of 1 is equal to negative 1. And then we have, that's 1 equals negative 1. That's not a true statement. So that is not a solution. That is an extraneous solution. And let's go ahead and plug the other number in. We're going to put in 3. And when I put 3 into this other side, 3 minus 1 is 2. Hopefully this gives us 2. It does, 2. So my only solution to this one is x equals 3. Let's go ahead and look at number 10. 10 says, given the functions, blah, 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 set up and simplify the following. So let's go ahead and set these up. These are composite functions. Let's start with h of g of x. I put h of g of x in. So I'm taking all of g of x and plugging in h of x. Let me go ahead and color code these. I'm just going to call H is going to be my red one, G is going to be my blue one, and F of X is going to be my pink one. Makes a difference to y'all. G of X, so I'm going to take that G of X and put it into H. So I'm going to write all of my H out, h is 2x. So 2, and instead of x, I'm going to go ahead and put g in. G is all of this mess. We have x plus 6 over 2. Once I get to this point right here, I just simplify. So I have these two, those canceled like that. I'm left with x plus 6. There's nothing else for me to do, so this is x plus 6. Now let's try g of h of x. So it's like the first one, except I'm switching them. So I'm actually going to start with the g's on the outside. So I start with my x on top. Which is h in this case. So I'm going to take this 2x and put it in there. So I have 2x instead of x there. And then I simplify it. 2x plus 6, that gets us 2x plus 6 divided by 2. Both of these numbers are divisible by 2. So I have x plus 3. 2 divided by 2 is 1. 6 divided by 2 is 3. X plus 3. On the test, I would like for you to go down to this one. I might be generous and give you all that. But I would like for this x plus 3 to be your answer. Last one, g of f of x. G of f of x. So g, the outside one, it's going to look like this one over here. Plus 6, 2, and inside my x right here, I'm going to put f. My f is 4x minus 3. If I simplify the top, I get 4x minus 3 plus 6. So I will have 4x minus 3 and plus 6 are going to be plus 3 over 2. There's not really much I can do with that. I'll more than likely take this answer. Then again, I could simplify both these. If I simplify these, that's 2x plus 3 over 2. But again, I'll also take that for this one, because that does not simplify.